Class, this is Mr. Watlington. Welcome to CIS 225, CIS 225 Network Routing and Protocols. What we're going to go through is just what I call a refresh. This is a subnetting refresh. I know some of you guys probably had CIS 150 a long time ago and you've forgotten a lot about subnetting, and there may be some people in the class who maybe missed CIS 150 or the prerequisite classes, and you don't really quite grasp subnetting. We're going to get into this. Now, the way I like to teach everything is with analogies, okay? And I'm going to use this analogy to teach subnetting. Analogy I call my bingo. Yes, bingo subnetting analogy. All right, here we go. Let's say that you are the owner of a bingo hall. You know bingo, yeah? You know, call the numbers. Right, so you got this big room. You know, this is your bingo hall. It can hold, and it can have 256 chairs in that bingo hall, okay? However, if you know anything about bingo, you got to have two people to help you out with this game. One is the person who calls the numbers, right? That's the person who gets the little balls and or whatever, the tickets, and call the numbers. The second person is the person who goes around and checks the cards when somebody says, "Hey, bingo! I've got bingo." So those are the two people that, you know, it's got to be at every game. So no, even though I have 256 chairs in this room, 2 of these chairs are allocated for the caller and the checker. So now I can, which means with this one big increment, this one big room, I can only have 254 active people who can play or host, that I can host into this bingo hall. Okay, good. Now, let's say business is going great. You've got people who say, hey, you know what? I like to play a little bit higher dollar bingo, you know, worth more money. And you go, and there's other people, I can't afford it. So what do you want to do? Because you want to accommodate everybody. You say, you know what? Well, what if I subnet, or what if I divide my hall in half and set up 2 rooms? I just put a partition in here, and now I got 2 rooms. Now I still got the same number of chairs, right? That doesn't change. I still got one overall big room. So, but when I partition this room, now I can have 2 rooms, one with 128 chairs, another room with 128 chairs. So that's what I've done. I split the room in half, had 2 games going at the same time, and I have 128 chairs. However, if you remember the thing with bingo, right? I still got to have a caller and a checker in each room. So as you see the red chair, this is my caller chair, this is my checker chair. For this room, caller chair, checker here. So in effect, I can only have 126 hosts. I can only host 126 people to play bingo in each hall. 126 here and 126 there. You're going along, things are going great. People are loving this. And then you got some other people say, you know what? This is so much fun. I want to play even higher dollar. Hey, can you maybe put us all in another room? And you say, of course I can. So you do another subnet, or you do another partition, and you divide your bingo hall into 4 pieces. 4 rooms, all right? But the same thing exists, okay? So now I got 4 rooms, I got 64 chairs, 64, 64, and 64. If you do the math, that comes back out again to 256, because that's all we have is 256 chairs. And yes, you're right, in each room I have to have that caller and that checker. So now instead of being able to host 64 people per room, I can only host 62. So I have 62 here, 62, 62, and 62 per room. So I've got 4 increments, right, of 64 with 62 players. All right. And I think you see where we're going here, right? Hopefully you've seen the pattern. I can just keep doing this as many times as I want. I can now split it up into, or partition this into 8 rooms, 8 small rooms with 32 chairs in each room. And still the math comes out the same, 256, because that's all I'm dealing with. And as you see, each room that has bingo got to have that caller or checker. So now even though I got 32 chairs, I can only host 30 people, 30, 30, 30. So now I've basically subnetted my bingo hall into 8 rooms with 30 people per, or 30 chairs per room, plus the caller and the checker. So what you see we've done in this scenario, we've subnetted the rooms. Think of the rooms as sub networks, and think of the chairs as hosts, as we take this analogy into the world of IP addresses. Now, just like in our scenario, in the world of IP, the same thing exists. The first and the last chair, or the first and the last IP address of every subnet cannot be used as a can't be assigned as a host. In the IP world, we call the first one the network ID, and the last one is the broadcast address. The network ID, broadcast address. Okay, so now let's flip this over and just take it into the world of actually, excuse me, from bingo to IP. First thing we want to talk about is some of this, how we annotate subnetting. 3 different ways we can do this. We can do it binary, we can annotate it as dotted decimal, or CIDR. The CID, or the class list, interdomain routing annotation, how we annotate. That's what CIDR stands for. Okay, so we look at it at a IPv4, and what we're talking about here is all IPv4, 32-bit IPv4. We take that 32 bits and we break it up into 4 octets with 8 bits per octet, right? Octet 1, octet 2, octet 3, octet 4. That will be the binary, and we can annotate that. Now the associated dotted decimal, okay, if you can just kind of follow the color codes, this first octet of blue, 8 ones there gives you 225. The red, 8 ones, 225. The brown, 8 ones, 225. And you see over here in this 4th octet, the purple, all zeros, that gives me the zeros. So I've got what? 8, 16, 24 ones. 8, 16, 24 ones. So this is the same from binary. This would be the dotted decimal equivalent. And if you don't remember that, to kind of give you that quick refresh, this is when we talk about, per octet, this is how we get these octets. I mean, the numbers in each octet. This is 2 to the n. So if we start over here, right? If you remember, 2 to the 0, any number raised to the power of 0 is what? 1. Yes. 2 to the 1 is 2. 2 to the 2 is 4. 2 to the 3, which is 2 times 2 is 4, times 2 is 8. 2 to the 4, which is 2 times 2 is 4, times 2 is 8, times 2, 16. As you see the pattern. Now, okay, all the way up 2 to the 5, which is 32, 2 to the 6, and all the way up to 2 to the 7. This is your 8 ones. That's where these ones come from. And that's important to note, and we're going to build on that. Now, if we look at from the CIDR, right? All CIDR is doing is counting the ones. That's all it's doing. So when you see an IP address with a /24, that means that the subnet mask for that IP address is 88824. That's all it is. Okay. Let's do another example. All right. So what we got this time? We've got 8, right? 1 to first octet. We got 8 ones in the second octet. We got 2 ones in the third octet. If we got 2 ones, that means we've got 6 zeros, and then the 4th octet. So now we're looking at a class B IP address subnet. This would be a class C IP address subnet. And when we look at that, that gives us 255.255.192.0. You may say, well, where did that 192 come from? All right, go into our chart here. If you remember, and by the way, if we do the CIDR, that gives us 18. Why? Because there's 18 ones. There's 8, 16, 17, 18. That's where that 18 comes from, just counting the ones. So how do we get that 192, you may ask? Good question. Good question. Let's talk about that. So like I said, if we're just counting the ones, 225, that would be all ones in that first octet. 225, all ones in that second octet. And you look at this third octet, I have 2 ones. So all I'm really doing is using these first 2 ones, which is 128, that first one, plus 64, which is that second one. 128 plus 64 equals 192. That's where that 192 comes from, because we're only using the first 2 ones, which is 128, 64. 128, 64. You add those 2 together, that gives you 192. Let's say if we were using the first 4, this is just kind of, just to show you the pattern. If we're using the first 4 ones, that would be 128 plus 64 plus 32 plus 16. That would give you .240. That would be there. Let's take it out even farther, and let's say if we're using the first 6 ones here, what would it be? I'll give you a minute to think about it before I give you the answer. Okay, time's up. So that'll be 128 plus 64 plus 32 plus 16 plus 8 plus 4. You add all those together, and that's where that dot, it'll be dot 252. So that will be the subnet 255.255.252.0 in this example. So like I say, everything that's a 1 is a network. Everything that's a 0, those would be your host. In this example up here, all of these would be networks, and now I could have 254 hosts. Actually, because there's a total of 256, but the first and the last aren't used. That's where you get the 254 hosts. And if you did the same thing here, this would be 128, 256, and you keep counting out, and this would give you a whole lot of hosts if you count all of those zeros, and if you kept going. So that is how we annotate, do subnet masking annotation, right? Whether it's binary, whether it's dotted decimal, whether it's CIDR, it's all the same. Okay, so now let's look at something that's very fundamental in understanding subnetting. It's what I call your subnetting calculation table. And what this shows you, this really helps you from trying to do a lot of anding and all these other things. If you're going on websites and you're looking at subnetting, you see a lot of different things going on at the same time. To me, this makes subnetting a little bit easier. Okay, now this table right here is actually, this is for a Class C IP address, subnetting. So 255.255.255.0. So what this table gives us first, it gives us the mask. And then it gives us the CIDR. Then it's going to give us the number of hosts you can have based on that mask, the number of subnets you can have based on the mask, and how many time it increments, just like in our analogy with the bingo hall, how many, the increment or the count. All right. So to give you an example of that, if we look at a subnet mask of /25, that mask is 128. Now with 128, that means there's 2 subnets, and the number of hosts that you can have is 128 minus the 2 that you can't assign, the network ID and the broadcast address. So you can have 126 hosts. If I do the 192, like we did the math before, which is 128 plus 64, so with a subnet mask of 192, the CIDR, the number of bits is going to be 26. Why? Because I am taking 2 bits. I'm using the first 2 bits of that 4th octet. That will give me 64 total hosts, but I can only use or assign 62. I can have a total of 4 networks, and it increments every 64. So there's going to be 64 IP addresses, 64 IP addresses, 64 IP addresses, and 64 IP addresses. Likewise, if you look over here at the .224 or the 27, that's 3 bits. That's being used, 3 additional bits, 24, 25, 26, 27. That'll give me 32 host IP addresses. I can only assign 30, 8 subnets, and it's going to increment every 32. So, and it keeps going, okay, all that way down to the last amount of usable hosts, because down here, these, you just don't have enough hosts that you can actually assign. Same thing happens when we look at a Class B IP address. Now the difference Class B, now we are incrementing the 3rd octet as opposed to the 4th octet. That's what we're talking about now, 255.255.0.0. So now we're incrementing that 3rd. So you see what happens, kind of the same thing happens, but this gives you the ability to have a whole lot more host addresses. So now if we look at it at everything else is the same. Like I say, our mask in that 3rd octet would still be 128, 192, 224, 240, 248, 252, and so on. But what it gives us now, because we're in the 3rd octet, the number of hosts goes up quite a bit. Because if I was in the 4th octet, you see it stops at 128 or 126 assignable. However, if I just keep going, the next one, which would be 2 to the 8, would be 254 hosts. 2 to the 9th would be 210 assignable hosts to 1022, and you see it just keeps doubling, keeps doubling. So if I use this whole third octet, I would have potentially 32,766 hosts that I could assign, IP addresses, assignable IP addresses. But everything else stays the same within, but I'm just using it on this third octet as opposed to the last octet. And if I am subnetting the third octet, that fourth octet is going to be a 0. Okay, so that's always going to be a 0. And just as an example, so let's say that I'm subnetting and my number of bits is 22, or CIDR 22. So what that is telling me that I'm using 255, 255, and I'm using the first 1, 2, 3, 4, 5, 6 bits of that third octet. So I'm using 8 bits from the first octet, 8 bits from the second octet, and 6 bits from the third octet, which gives me 22. 8 and 8 is 16 plus 6 is 22. Now, if I subnet to there, now the rest of these will all be zeros. This will be 0, 0, and the last 8 zeros in the fourth octet. That gives me how many? It gives me a 1,022 assignable host. That's 1,022 IP addresses. It also gives me up to 64 subnets, a total of 64. Now, what it also does, this column here is very important, increments. It increments on 4, meaning that it's assigned in groups of 4. So that's what this increment is telling you. Actually, so if you have here, if it was 128, it would increment in groups of 128, every 128. Here, it's every sets of 4. So that's this subnetting table should help you kind of understand how the math behind subnetting, so you don't have to do a lot of the counting the ones and all those. Everything correlates. It'll make a little more sense as we go through a couple of examples. Speaking of examples, here's one right here. And I kind of went back, yeah, you recognize this. Okay, let's say this is your bingo hall, but really let's call it a network. So that you want to have 2 networks, subnetworks with 128 hosts each, right? Subnet 1, I want 128 minus 2. So I want 126 usable hosts. Subnet 2, same thing, 128 minus 2. That gives me 126 usable hosts. Here's my handy dandy table. So if I need 126 hosts total, right? So I have to start here. Why? Because this line up here, which gives me the number of hosts, 62 is too small. So I've got to start with 128. So that tells me right there where I'm going to start my subnetting. To be able to get 126 hosts, I have to subnet at 128. All right? Now, what does this also tell me? It tells me how many bits. That's going to be /25. So it's going to take all of the first 3 octets, 8 plus 8 plus 8, and it's going to use the first bit of the 4th octet. So if, this becomes a network bit, and if I add the rest of this together, guess what it gives me? 128. If I add together, the 64, the 32, 16, 8, 4, 2, and 1. So now that tells me how I'm going to increment. So for this example, I'm going to use the IP address 192.168.10.0/24, which means 255.255.255.0. So using all that, now let's actually do the subnetting, okay? So I know what my network ID, 192.168.10.0. That's my network ID, right? So now subnetting with 128. So my first, this is my network ID. I can't assign this. So the first IP address I can assign is going to be 1. Be 192.168.10.1. Like I said, I've got 128, but I can only assign 126. That tells me 126 IP address later, my last host is going to be 126. Now, the other one that I could not assign was my broadcast address. Just like when we were talking about bingo, you had the caller and the checker. Think of the first of the network ID as the caller, the broadcast address as the checker. These are the two that I can't assign. So now my first IP subnet range is going to be 192.168.10.1. The last one is going to be 192.168.10.126. And I can't assign 127. So how many did I need? I got 126, and that's how many I've got. So I say, and now how would I annotate that? So the subnet ID would be 192.168.10.0 with a subnet mask of /25. And /25, that tells me that my mask is .128. So if I write that out, 255.255.255.128. So that's my subnet ID, and that's the mask. Let's take a look at our second subnet. So that right there just finished up my first subnet. But I have two. I want two subnets. So this is my second subnet. Where does this one have to start at? Because the last IP address I used was 127. I've already used those. So now this one has to start at 128. So now the network ID for the second subnet is 192.168.10.128. I'm incrementing by what? 128, right? That's my increment. So with 128, my first assignable is going to be 129 because I can't use the network ID. And the last assignable is going to be 254. The broadcast is going to be 255. So the first subnet is the first 128 with the 126 assignable. The second subnet is going to be 128 with 126 assignable. But it starts at 128 because the first subnet uses 1 through 127. At the end of the day, I still have to only have 256 in this octet, in this fourth octet that I can assign. And if I look at the subnet mask, the subnet ID, it's going to be 192.168.10.128/25. So that is how I would do a subnet to get these two subnetworks completed. So when we're looking at these, a couple of things this tells you. Your subnet ID, that tells you what the where the IP range starts. Here, the IP range starts at 0, right? And then it assigns 128. So from 0 to 127 is 128 IP addresses. Because I've already used 127, my next subnet has to start where? Logically at, yes, 128. So actually this right here, the subnet ID will always tell you where that range is going to start. And then I'm going to assign from 128 the other 128 IP addresses. The second, the subnet mask, that tells you the range of 100. Like for instance, in this case, it's 128. It starts at, like this first subnet starts at 0 and assigns 128. Second one starts at 128 and it assigns another 128, which is going to take me to 256. The total amount of IP, 255. The total amount of IP addresses that I have available. Okay, let's do another quick example. This one, actually, this is now, let's say we wanted to set it up with the 64 hosts and 4 subnets. So we got 4 subnets, right? And we got 62 hosts per subnet, 64 minus 2. Same thing, we go to our handy dandy table. So if I need 62 hosts, where do I have to start at? As a minimum, I got to start here because 30, 14, none of those will give it to me. 128, I could go there, but that's going to be a big waste of, that's going to be wasting about 64 additional IP addresses. So I'm going to start right here. Now, if I start there, where is my subnet mask? .192. And if you remember where that 192 come from, it's 128 plus 64. That's where because that tells me now I'm using the first 2 ones in that octet. These are going to be ones. These are going to be used as network, and the rest of these will be host. Again, if I add these up, 1, 2, 4, 8, 16, 32, it's going to give me 64. That's where that comes from. Okay, same thing. Let's use the same IP address. 192.168.10.0 with a subnet mask of 24, which is 255, 255, 255.0. 8 plus 8 plus 8, 24. Okay, so doing the same math as we did before, if I look at my first subnet, if you remember the ID tells me where it's going to start at, which is 0, 192.168.10.0. The first host is going to be 1. Now I'm incrementing by 64 this time, okay? That's what my mask tells me, that I am incrementing by 64. So the first host, 64. The second, and the last host that I can assign is going to be 62. The broadcast is going to be 63. So from 0 to 63, that is 64 IP addresses. However, only 1 to 62 can be assigned. So that's my first subnet. First subnet goes from 0 to 63. If I look at the CIDR, it's what, 26. So that is what my new subnet mask is going to be. 192.168.10.0/26. Or if I want to write it out, 255.255.255.192. The 192, if you remember, came from adding, because I'm using the second set of the first two ones in this octet. 128 plus 64 gives me that 192. Okay, that's our first subnet. The second subnet is going to start where that one left off. So it's going to start at 64. 192.168.10.64. First assignable host is going to be what? 65. Yes. The last assignable host, 62 later, is going to be 126. So I can assign these to my second subnet. And the broadcast for this one is going to be 127. And as you see, what changes is my subnet ID, because it, started the wrong place, did I? I forgot to update that one. This should be 64 right there. That was a mistake on my slide. Now, the third subnet is going to start at 64 and do the same thing. So that's how we continue to build out our subnets from 0, 64, 128, 192. So that is going to how we can build out all four of those subnets.